The Kenya Space Agency is set to launch its second nanosatellite christened Taifa 1 in April this year in California, United States of America. Taifa 1 satellite is an Earth observation satellite with a payload designed to provide multispectral imagery of Kenya that will be useful for environmental monitoring, natural resources management, agriculture, disaster risk mitigation and security, among others. The satellite will be a game changer in enhancing Kenya's access to real-time data that is crucial in socio-economic development spheres such as urban planning, agriculture, reforestation, climate change, telemedicine, among others.
Increasingly, government are making decisions based on data on various issues. The best platform and instrument to collect data is satellite. Data on agriculture, data on minerals, data on energy, data on our forest cover, data on urbanization. So the best instrument to capture data now, in the age we are in, is satellite.
Obtaining reliable and cost-effective data is critical in addressing societal changes effectively. Therefore, satellite data can be used by the government to improve its ways of predicting calamities, detecting security threats, managing natural resources, and regulating urbanization.
For satellite communications, or generally having data from an asset in space, you need to have a ground receiver station that you will use to download the data or will be in communication with the satellite. It will be tracking that satellite so that every time it is overhead Kenya, remember this is a satellite that is going around the Earth, and every time it is overhead Kenya, that is the time our ground receiver station is going to establish a link with the satellite and download the data. These are imagery data. So as now to see how that is connected to the farmer. So if, for example, you use that satellite imagery to characterize the condition of crops, for example, you are able to say that this is land that is under maize. And because that satellite will be going over Kenya every time, so there will be a series of those imageries which with the right kind of hardware on the ground receiver station, you are able to look at the progression of, for example, that farm, okay, and see the condition of that crop.
To manage all space-related activities in the country, the National Space Secretariat was established in 2009, which later transitioned into the Kenya Space Agency in 2017, following the approval of the Kenya Space Policy, the Kenya Space Strategy, and the Kenya Space Agency Executive Order by Cabinet in the year 2016.
The Kenya Space Agency is a premier space organization that was created by the government of Kenya to facilitate the development of space programs in Kenya.
The Kenya Space Agency has shown beyond reasonable doubt that it is growing over a period of time. And today I'm happy to report that I think Kenya Space Agency has the potential, has the capacity to be a leader in Africa and in the global world.
Due to the miniaturization of electronics and components, satellite technology has become cheaper and more accessible, resulting in nanosatellites having more capabilities while being affordable.
The fact that it is affordable means that it is something that we can do without taking too much resources from those critical areas like health, food security, water management, because big satellites would cost a lot of money. So nanosatellites is the way to go, and I think in future where we are going is to have a constellation of them.
In international space law, just as we have maritime and air law, in international space law there are treaties or rules that govern how state actors and non-state actors operate or conduct activities in space. So for Kenya, the agency is the one that controls how entities can conduct the activities in space. This is because each object or each act of a citizen or an entity is the responsibility of the country or the government in that matter.
The satellite is set to spur Kenya's role not just as a consumer of space data, but also an active player in the quest to strengthen the space agenda.
Space technology is critical. It's critical for the military, it's critical for government in improving the socio-economic aspects of its people. Kenya is on the equator. And Kenya being in the equator, then it is a very, very important position globally to collect data from the space.
In the development of Taifa 1 nanosatellite, a team of Kenyan engineers, both electrical and mechanical, were identified to implement the project. They underwent a customized training on the space environment, orbital mechanics, and design of space systems to be able to understand and design a mission that would survive the extreme space environment.
The Human Resource Department and the Kenya Space Agency sourced and engaged electrical engineers, mechanical engineers who were trained to develop the Taifa 1 satellite.
We have had a long journey coming up to this point, and I'm also happy to present that apart from this development, we have also been able to do additional hardware. This board that I have with me here today is the Sayari Labs payload processor, which we designed internally fully at this facility and has gone to space. So it is a radio module that we believe that once successfully tested in space will be able to support our future missions.
In my role as a team lead, I was responsible in coordinating between our team that is developing the subsystems here in Kenya and also our partners outside. In the coordination, we were doing a lot of communication as well as ensuring that all the subsystems are on the same page. Another component is that we were doing reports where we were able to document all the subsystems to make sure that everything is well documented and can be followed by any team member within the team.
Taifa 1 is a 3U satellite. When you talk about 3U, we say it is in a class of nanosatellites. We have other satellites which are bigger, but for this case it is a nanosatellite, and its dimensions are 10 centimeter by 10 centimeter by 30 centimeter. So when we talk about the structures, we are talking about the frame that houses all other subsystems of the satellite. The structure is something like this. So it houses all other subsystems, and the other subsystems include the onboard computer, the communication subsystem, the electric power subsystem. There is the attitude determination and control subsystem, and then there is the payload.
After the launch, our role as electrical engineers will be to operate the satellite and also to monitor the performance of the satellite, making sure that every parameter that was set and every functionality that the satellite is supposed to perform performs well, and also monitoring the health checks of the satellite.
So what I'm in charge of with the Taifa 1 mission is the ground receiving station and applications. What generally happens at the ground applications and receiving station is where we receive the commands or the request from the stakeholders on the type of data they want, the type of location where they want, and that is where the mission's operations also take place.
The space sector has a wide array of stakeholders. There is government, who are key stakeholders, because essentially most of the applications, we are not usually the end users. We develop systems which are supposed to inform decisions in other regions.
For Earth observation alone, I can say there's virtually a host of users who utilize data from Earth observation.
Here at ICPAC, one of the things that we are doing specifically in the IGA Disaster Operations Center is building early warning applications, which we believe will be able to help our member states act early before the disaster hits. One of the key components of early warning systems is Earth observation data, and that is where Kenya Space Agency comes in. We use a lot of Earth observation data from different satellites at the moment to be able to build applications that can be used to inform decisions and policies as well. We're really looking forward to integrating the data from Taifa 1 into the systems that we're developing here at ICPAC.
Locate IT, or what sometimes people refer to as Locate It, is a geo-ICT company based here in Nairobi, Kenya. So Locate It and Kenya Space Agency have been partnering over the last couple of years on very specifically a project we call Africultures, which is use of remote sensing technologies to enhance agricultural productivity in Africa. And this presents an opportunity for us to continue developing applications that will serve and address our societal needs.
My name is Kenneth Chepkwony. I'm a program manager at Tomorrow Now, which is a non-profit that works to bridge the gap between next generation weather and climate solutions and communities that need them most. We do this by leveraging philanthropic capital as well as innovative partnerships with organizations including Kenya Space Agency, who've been a key stakeholder that we've been keen to work with. So Tomorrow Now is currently working on an MOU with the Kenya Space Agency, and the idea will be to leverage some of the quality data that the Kenya Space Agency is looking to generate and what they already have.
Yes, so Akiba Mashinani Trust supports a group of people living in informal settlements known as Muungano wa Vijiji, who have come together to advocate for the rights of the people that are living in the informal settlements. So the launch of this new satellite, I believe it's going to make the work that Akiba Mashinani Trust does more easier, in that we'll be able to get a clearer imagery. So what we do in most cases is that we get images from satellite imageries, we digitize them to come up with shapefiles. And one of the challenges that we get is that some of these images are not very clear. So we are hoping that these images from this new satellite are going to be clearer, and that will make our mapping exercise very simple.
The DRSS stands for Directorate of Resource Survey and Remote Sensing. The relationship between DRSS and the Kenya Space Agency has been there for quite a long time, since the inception. And this is due to the fact that actually both institutions are applying remote sensing technology in implementation of their core mandate. So there's the issue of application of satellite data in undertaking most of the programs that address socio-economical issues in Kenya. So these two institutions have been in collaboration for quite a long time. In fact, we also have a memorandum of understanding between the two institutions that affirms the strong relationship between these two agencies.
Kenya's historic launch of the Taifa 1 nanosatellite will be incomplete without a brief look into history. Kenya's forays into space dates back to 1964, when the San Marco Equatorial Range, now known as the Luigi Broglio Malindi Space Center, was established. As a result of the strides, the first satellite, San Marco 2, was launched into orbit from the Malindi-based station on 26 April 1967. Thereafter, the Kenyan space industry has grown in leaps and bounds, totaling 9 satellites and 15 sounding rockets launched in a span of 2 decades from 1967 and 1988 from Malindi, Kenya. Moving up the ladder, Kenya launched its first satellite in March 2018. The 1U nanosatellite, named the first Kenyan University nanosatellite precursor flight, was developed by the University of Nairobi with technical assistance from Japan Aerospace Exploration Agency under the auspices of the United Nations Office of Outer Space Affairs Access to Space for All initiative. The 2018 satellite mission served as a crucial springboard in Kenya's quest to not only venture into space, but also make use of vital data thereof. It also demonstrated great potential of the Kenyan people in design and development of space systems.
What we have started with now is mostly capacity building, training and research. And we have a collaborative means of doing this with our institutions of higher learning, where we give them grants and then they develop products that are related to space programs. On the other hand, we also have an outreach program where we reach out to primary schools and secondary schools to be able to create an interest in space matters so that our children can have some motivation, some interest in science subjects, in geography, in technology subjects, in mathematics and science, so that in future we have a pool of scientists and engineers that are able to deal with math as space. Because this is a new frontier for all countries, and we don't want to be left behind.
And for the young children, the young kids, those in primary school, those in secondary school, the young people, they are those who see and talk about space because they see it on TV. Now it's no longer on TV in Western world countries. Now the launch of satellite is now in Kenya.
The launch of Taifa 1 nanosatellite by the Kenya Space Agency is without doubt a game changer, a timely intervention to bring the future to the present.